Okay, this is just a test or the first take of this video. We're gonna look at Planetside models, which are stored here in UBR files, as we can suppose. We have the big file, some small file for vehicles, and some more files. We'll take just one of them and look inside these vehicles. In hex, we see Uber and 1 here. We don't care about that. Then we see some numbers, integer numbers here, and then we see some names. These are probably names of the models. Since we can, let's scroll it a bit. So we will start from the beginning of the line, and we can see they have fixed size. Like every other name starts from the same size. We can count all these names and see we have 1A in hex of them, which is 26. If we go back to header, we can see 1A is one of the numbers here, so we can be sure this is a number of models in this file. What the other numbers are, we don't know. We don't even know where the record about the model begins. It may begin here, or just start with the name. We don't know that. But if we scroll down there to the last one, we can see the name and 4 numbers above that, and then some zeros and 4 more numbers which are similar to this one. 17 something, 18 something, 6 something, 6. So probably we can say that this one is a record for the last model, which is Vanguard, and these 4 numbers are describing this model. Okay, so if that's true, let's go up to the first model then. This will be the first model. Its name is AMS, and instead of these numbers there are all zeros, which is normal. The first model will probably start from the beginning of data blocks or something, so it has all zeros here. Next model is AMS spawn doors or something, and these are 4 numbers for it, which are a little bigger. Of course they are bigger. And next one, they will increase and go up to the maximum numbers of the last model. So these numbers before the first model is something we don't know. We have 7 numbers here. In most games, in a model description, we have sizes, like a size of a vertices part, size of a faces part, and so on. But in this game, it looks like we have these not as sizes, but like an offset. So this is a offset of some section for this particular model. This is the offset for next one. And we can go back to the last model and check it against the numbers in a header. For this, we have something like multi-window interface here. We can open another window here, and this will be our header. This is our last model. Let's check these numbers. we have something like A8 something. There is nothing like it here. 73 again. And then this number starting from 3 is just a little smaller than this one. And next one starting from 6, 6 again, 19, 18, 7, and 7. These numbers are probably the full size of 4 sections. And these numbers, for each model, they are offsets inside of these sections in the file. This one last number, we don't know what it is. We can say anything more about these model records in the table in the beginning. So let's proceed in the file what goes next. This is an array of some float numbers. These look like float numbers. This byte 40, 3F, 40, 40, 3F again. This tells me that these are floating point numbers. That's probably coordinates, vertex coordinates. And there are lots of them. If we scroll down and down, there will be more and more of them. And I already have written where they will end. And let's go there. Here, you see lots of numbers, and then they end, and then some integer indices starting from 0, 1, 2, 3, but they are not sequential. If you scroll a bit down, you can see some of them bigger, some of them smaller. Anyway, there will be lots of them. And again, I already have written down the offset where they will end. They will end here. So these are one of the last indices. So they go up to A7 something and A8 something, and here this is probably the last one of them, A542 or something. So I have this offset recorded. And we have seen a number such as this somewhere. Let's return to our header. A8, 27. This is some count, probably corresponding to these counts inside of these indices. We don't know what these are yet, but let's remember that. So now our file will look something like this. First we have a very small header, this one. Now we have a model table, then a big array of numbers, and then some indices. And these are offsets for these big parts of the file. We can see that now we are somewhere in the middle of the file. So this part, it's not in a real scale, but these two parts take a very big part of the whole file. So we can safely say that these numbers are not for just one model. They are probably shared by all models in the file. And these indices pointing to something, these are probably also shared. Now, after these indices, we have something looking like 2-byte integer numbers. And this is how usually faces look in the files. They will start from 0 and some small numbers, then they will increase. This is definitely some kind of phase buffer or phase indices, like they can be called. If we can go down, we'll see lots of them again and again. Then we'll some more indices. Then again phase indices, even some table with some floating point numbers again. But this table is very small. And after that we have phases again. We don't know what this is. It's probably some next big section of the file. We can return to it later. Now let's go back to our floats and indices. Let's count how many we have. We have offsets. We can count how many bytes we have and how many numbers we have. Okay, let's B860 minus 84C. This is the count of bytes, the size of this float array. We don't have anything looking like this number in header or anywhere else. If we divide it by 4, we'll get a number of floats here, because each float takes 4 bytes. No luck again, this number does not correspond to anything here. And even if we see maybe this XYZ, like 3 floats for each coordinate, for each vertex, and divided by 3 again, this number again will not tell us anything. So let's go to the size of next part. It will be minus this. This is the size of indices part, and each index is 4 bytes, and this is the count of indices here in this blue part. And now we can see this number here in our header. This means that this number in header, this is the number of indices here. Okay, so maybe these are vertices, as we thought, and these are their indices. How can we check that? We have this many indices. Each index will have a number from 0 to AA27, and this will probably point to this big table or big array of floats. Let's check this. If we have that many vertices, each will take 12 bytes, like C in hex. This will be the size of vertex table if it's a vertex table. We can say this is smaller than the size of this array, like somewhere in the middle, like a bit more. Okay, this is possible. Maybe there is something else in this array, but the first part may be vertices. Let's go here. So there is nothing else than these floats here. Like first one is 40, 3F, 40. 40, 3F, 40 again. 40, 3F, 40. It really looks like XYZ, XYZ or something. It could be like XYZ and normal XYZ and tangent or texture coordinates or something else, but this array looks like it's only coordinates like X, Y, and Z. So, if that's true, then we can say in our first model, that's the first number is 0 to this number, has that many indices. These indices will point to the first big table, which will be real coordinates of our model. So we can write a small test program that will take indices, find a vertex here in this table, and put it into some small example geometry file that we can load into Blender to check this. I will not show this, just show the result. Open Blender, and we can see these vertices here. We can safely say that this is some kind of vehicle. We see 6 wheels, cabin, steering wheel. This is something called point cloud, just vertices and nothing else. But anyway, we already can see this is some kind of a model. So now we can say that the first part, like about half of this array, is actually model coordinates for all the models in this file. But what's the remaining part? Let's subtract the size. It was this minus the part. This is the size of remaining part. It must be somewhere here. This will not correspond to anything in header, in bytes at least. But what if it's some kind of count again? Not the size in bytes, but some count. It can be 8 bytes, 12 bytes, 4 bytes, like anything. So if we just divide this say by 4, there is nothing looking like it back. And if we divide by 8, oh, now we 73, 88, 98. This is the second number in our header. So this will be a number of elements in the first part of this float table, and this is a number of elements in the second part. If we multiply and add this, we'll have exactly the full size of this table. I checked that before. So each element here is 8 bytes, and they are all looking like floats. Then this part will be 2 floats each element. This probably can be texture coordinates like UVs. We can check this right now, but let's just say this will probably be UV coordinates. So the whole file will now look like this. Header model table, then a big array of floats for all models, vertex coordinates, UV coordinates, and now we can only say this is vertex part for all models again, which are indices for vertex coordinates. These UV coordinates are probably indexed too, and they must be somehow distributed between all models in this file. We don't know that either. Now let's return to the remaining data part and see what's there. In the beginning of it, as we already seen, there are something about faces, and they will go for a long time somewhere around here, and I will go right there now. This will be here. So these are faces. I went a little back. Faces, faces, faces. Some kind of table here. Indices. And then suddenly the pattern changes somewhere around here. This is not integer numbers, no face indices, this is something else. We can scroll down and see that there is no regular structure or pattern here in them. This is the most confusing part here, and it will belong to. Sometimes you see it looks like records here have fixed size of 16 or 8 bytes. And sometimes it's not like that. There is something else here. Anyway, if we scroll all the way down through this part, we'll go to something like this. This part will end here, and then we can see it changes to some kind of structure with names again. We don't know what this is yet. Some numbers between them, more names and more numbers, and now something like matrices, and these are probably identity matrices because there are only zeros and ones here. This is a 1 in float, and there are names for each matrix here, and then more names again, and then it repeats again. It looks like this is some kind of structure. Again, for each model it repeats, and it has names and matrices, probably bones or something, and this pattern will go until the end of the file. Well, since I already know the offsets where the pattern changes, I can calculate the sizes of all these 3 remaining parts I just found, like by subtracting the offsets between them, like it was here. There are 3 more parts here for something else. Okay, these sizes will be one more thing. We can't exactly know where this part begins, because if we scroll up, we can be sure that this is the place where the third part ends, and this is the place where the last part starts. It may be here, or even here, because we don't know the structure of either of these parts, but we can approximate the sizes. Like, say, it starts here, then size of the last part will be... this will be 77AC9. If it starts a few bytes later, the size will be a bit smaller. But anyway, if we look at this number, it's really close to this number in header. So it's almost... we can be almost sure that this is the size of the last part. Let's call it matrices and names part or something. And if we measure the size of the faces part, it will be something like this. Yes, in bytes again. So these 2 numbers are sizes of parts number 2 and 4, inside of a file, but we don't know, we can't find the size of third part. I will call this part just part 3. Its size is something around 1B, like this, in bytes. Again, this part can be just count of some elements with equal sizes. We can divide it by 4, and immediately we got a number very close to this number in header. So if not, we will divide it by 8, 20 or something, but it's a little bigger. We can just make this number and multiply it by 4, and now we have the exact size of part 3. We don't know what this part is about, so let's say we identified the 3 remaining parts, like faces part, part 3, and names and matrices part. We also have offsets for all these parts written here, where each part starts, because for each model we have offset inside of the part. So let's say faces for first model will be somewhere here, second model here, third model, and the last model here. The same for this matrices part, first model matrices, second model matrices, and so on. And we have only one number in header that's left unidentified, this one before the first name AMS. We don't need actually this number, but if we check this for a while against different numbers we've seen here, we can see that this number is exactly offset of the beginning of the part 3. We don't know what is part 3 yet, but somehow we have its offset written in header for some reason. We don't have offsets for other parts in header, but anyway we can easily calculate them because we know the sizes of each part, of this part, and every part and model table. We can calculate them now. Maybe the game just doesn't need all the offsets all the time. For some reason it only needs this part 3. Okay, so now we have reversed or researched all the basic structure of the Uber file, and we know how many models we have, their names. We know we can divide all these parts, break them into individual models. Like for each particular model, we can have its vertex part somewhere in the middle here, its faces part, and these parts too. And for the first part, we have indices that will point us to vertex coordinates, and we can build this models point cloud. That's all for today. Thanks for watching.